Hi, everyone. My name is Or. I'm a senior PM on the Lambda team. And I'm here today to talk to you about application lifecycle management in a serverless world. Since Lambda jump-started the serverless space about a year and 8 months ago, we've seen our customers build many different types of serverless applications with new use cases emerging literally every day. And with more and more customers both migrating to serverless and benefiting from it. If you came to Tim Wagner's State of the Union address, you heard examples like Vivo, who built their data and content platform using Lambda and can now scale up seamlessly to 80x their regular traffic. Or FINRA, who process 500 billion stock trades daily on Lambda. Now, we on the Lambda team, as the serverless space grows, we continue to collect feedback and listen to the challenges that our customers are facing. And specifically in the context of ALM and tooling, the main challenges that our customers are facing are the ones that you see on the screens behind me. First, how do I define a serverless application? One that is basically built out of resources. How do I construct those resources as one application, as one unit? Then, how do I deploy that application? And not only deploy it, but deploy it efficiently and deploy it consistently across either environments or accounts. And after I know how to deploy my application, how do I automate that process? How do I construct a release process that builds, tests, and deploys my application to multiple environments with every code change? And lastly, once my application is up and running, how do I monitor it? How do I troubleshoot it? And how do I quickly get down or identify the root cause of the problem? Now, before we jump into ALM, and we have a lot to cover in this session, let's quickly reiterate what a serverless application is. So it almost always starts with an event source. That event source can be an HTTP call, a put object into an S3 bucket, or any other of the Lambda-supported event sources out there. That event source then triggers your Lambda function, which could be written in Node.js, Python, Java, or the newly announced C#. And that function is running your code, right? So it can do whatever it is you'd like it to do. For example, return a result, or call a downstream service to continue processing, or write metadata into a database. Now, how does ALM for an app like this look like? Well, it looks pretty similar to the lifecycle of any other application that you would write or manage. You would start by authoring your Lambda function. You would then have to build your deployment package, which is a zip file that contains your code and any dependencies that your code relies on. You can then choose to locally test your function before deploying it to Lambda. Now, we have a bunch of tools that you could use to do this today. For example, the Lambda console, where you could use the inline editor to write your function, then deploy and test it. You could use Visual Studio for C# or Node, or Eclipse for Java, to author your function, locally test it, deploy it, and then even run it in the cloud from your IDE. Or you could go the third-party route and use any text editor, such as Sublime Text or Atom, and then use one of our ecosystem partners, such as Serverless.com or others, to simplify the subsequent steps of your release process. However, as the complexity of your application grows, some questions become increasingly important. For example, what if I have a large application that contains dozens of microservices and hundreds of AWS resources? How do I define it? How do I manage that as one unit, as an application? Or what if I have a large dev team that collaborates? How do I keep my definition in one centralized place where my team can efficiently collaborate on it? Well, the solution I'm going to offer to you today is to use SAM, which is powered by CloudFormation. And before we jump into SAM, let's start with a brief overview of what CloudFormation is for those of you who are not familiar with it. So CloudFormation is essentially a service that allows you to provision and then manage a collection of related resources. Now, in CloudFormation terms, that collection of resources is referred to as a stack, and a stack equals your application. And one of the ways you could create a stack is to write a template in either a JSON or a YAML. CloudFormation can then take that template and turn it into resources provisioned in your account. Now, SAM is a new specification that extends CloudFormation and is optimized for serverless. It allows you to define commonly used resources and serverless applications in a simpler and cleaner way, specifically Lambda functions, API gateway APIs, and DynamoDB tables. And it supports anything CloudFormation supports. So under the covers, it's essentially a CloudFormation template. And any CloudFormation resource you define within it is just going to work. Let's dig a bit deeper into how SAM or a SAM template looks like. So the first thing I'm doing here is defining a serverless function or a Lambda function. I then have to supply it with a code URI. And a code URI is a URI that points to an S3 object, which is supposed to be your deployment package for your Lambda function. One cool thing to note here is that I can define managed policies. And when CloudFormation generates my function's execution role, those managed policies are just going to be added to that execution role. In this next section, I'm defining my event source, which in this case is an API. I'm defining my API, the path and method. And the cool thing to note here is that I don't have to explicitly define an API resource to declare this API. By defining it as my event source, CloudFormation would know to generate the necessary API for me in API Gateway. And lastly, I'm defining my DynamoDB table. And by using simple table is essentially a shortcut that allows you to define a single attribute primary key DynamoDB table with provision throughput of 5. Now, the key piece that makes all this possible is the transform. The transform is a new CloudFormation capability that basically allows CloudFormation to turn this template into the regular CloudFormation template that CloudFormation knows how to interact with. And just in case you still aren't convinced that SAM was necessary, this is what it's turning into. So this is the CloudFormation template you would need to write to define this exact same application that you just saw one slide ago. So I think we can check off the first item of the list. We can use SAM to define our application, to write a template that defines all the resources within our serverless application. Now, how do we take that and deploy that, turn a template into resources provisioned in my account? The easiest way to do that is to use two new CloudFormation commands. Now, before we jump into the commands, let's think about what we had to do to deploy. We had to annotate that code URI property, right? So we would have to start by creating our deployment package, which essentially means zipping up our code. We'd then have to upload that deployment package to S3, and then annotate that code URI property to point to that deployment package. Now, if we had 100 functions within our template, we would have to do that 100 times. So luckily for us, the package command basically does all that for us. It takes the template, uploads a deployment package to S3, and then annotates all the code URI properties within that template for each and every function that I define in there. After it spits out my new template with the code URI properties, then I can call the deploy command. And the deploy command wraps two API calls to CloudFormation. The first one is create change set, which unsurprisingly creates a change set. And what a change set is it's the delta between your template and the resources provisioned in your account. So if I'm creating a new stack of resources, then obviously the change set is going to include everything that was in my template. But as we continue to update our stack, then it's only going to contain the delta. It then calls execute change set, which essentially just applies the changes in the change set to my stack. Now, let's do a quick demo of how that actually looks like. OK, so first of all, one cool thing we launched with SAM was the ability to export any blueprint as a SAM template. So let's just take a look at a simple S3 template or blueprint. You can click on the right on the icon here to download it. And what I get is a zip file that contains two files, my code and my template. And now, the only thing I'd like to show you here, or maybe a couple of things, the first one is that I have an empty code URI property, which I now need to fill. And the second thing is, as I promised you before, you can actually define any CloudFormation resource within the template. So along with my serverless resources, I'm defining a bucket. OK. Now, how do I turn this into resources in my account? So let me just navigate into that folder. And the first command I need to call is package. Now, what I need to supply to this command is my template, which is called template.yaml. I need to provide it with an S3 bucket, so it knows where to upload my deployment package to. I have a bucket called SAM artifacts. And lastly, I need to provide it with a name for the output template, the new template that it's going to generate for me, with the code URI properties already filled. So let's call this output.yaml. OK. So as you can see, I have a new YAML file called output. And it's identical to the template we saw before, only now I have an annotated code URI property that points to a deployment package in S3. And what the package did was essentially just zip up the folder. Now, the next command I need to call is deploy. And what deploy gets is, again, a template. And we are now going to provide the new template that my package command generated for me. I need to provide it with a stack name. Let's call it my application. And the last thing I need to provide it with is the ability to create IAM roles, since it has to generate my execution role, my functions execution role for me. And now, while my change set is being created and executed, one thing I'd like to note here is that there's a reason those two APIs are separate. So the whole notion here is that you could actually call create change set and then view the delta, view the changes that are going to be applied to your stack before calling execute. So if you'd like to use that capability, you could either call the two APIs separately, or you could call deploy and provide it with a property that tells it to only call create change set instead of create and then execute. Now, one more thing I'd like to show you is a cool capability in the CloudFormation console that is called a designer. The designer essentially allows you to view all the resources in your stack and the connections between them. Let's see if my stack has been created. And if I just check it, I can click on View Template in Designer. And this is how it would look like. So I can see my Lambda function. This is my bucket that is going to invoke it. And then permissions necessary for my function to work. So I have my execution role here. And my resource policy, which actually lives on my function, but allows my bucket to invoke the Lambda function. Oh, sorry. OK. So far, we've defined a template. We've seen how to define an application within a SAM template. We then saw how to efficiently deploy that template, and consistently as well, because each time you call package and command, package and deploy, the same thing happens, right? It's the same template and the same deployment package that are then being deployed across your environments or applications. So it's essentially the same stack being deployed over and over again. Now, I know that for most of you, that's not enough. You need to have a way to automate that process. You need to have a way to automatically be able to build and test and deploy your application. Now, the way we are going to do that is with a service that's called CodePipeline. And CodePipeline is a continuous delivery service for fast and reliable application updates. It allows you to build, test, and deploy your application with every code change based on stages that you define in your release process. And it essentially acts as an orchestrator. So it links together a host of third-party and AWS services to automate your release process. Now, this is how it looks like. And each rectangle you see there is actually a stage. And a stage is a logical representation of a stage in your release process, such as build or deploy. Within each stage, you can define one or more actions. And each action is an actual operation that's happening within that stage, such as an actual build action. Actions could be parallel. So for example, here I have a build action and also an action to notify my developers that a build had started. Or you could have sequential actions. So in this example, I have a build action and then a test action within my build stage. Now, after all actions have completed successfully within a stage, we have a transition to the next stage. So let's see how a pipeline looks like. But actually, before we can see how a pipeline looks like, we need to talk about one more thing, and that's CodeBuild. CodeBuild is a new service that AWS announced today, which is essentially a service that allows you to build and test your application in the cloud. It allows for concurrent builds, so it can scale continuously. And for each of those builds, you can compile your code, you can run local tests, and you can install packages. Now, in a serverless context, the really cool thing about CodeBuild is that it comes with managed environments for Java, Python, and Node. And now, what that means is, for Java, for example, that environment contains JUnits. So you can actually run tests within your build. For Node and Python, those environments contain NPM and pip. So you can install packages continuously and reliably as part of your automated release process, instead of having to zip it up or having to have it as part of your repository. Now let's take a look at a pipeline. And this is the structure of the pipeline that I'm about to show you. I have my source code in GitHub. That then triggers my build action, which is going to be my build stage, which is going to be CodeBuild. I then have a deployment stage to my beta environment, which is going to be using CloudFormation. Then I'm going to test my application using a third-party tool. And if that test succeeds, I'm going to deploy to my next stage, which I called prod. So let's see how that looks like. So this is my application. It's a pretty simple Lambda function triggered by an API gateway API. And here are my two stages. So I have my beta stage, and I have my prod stage. Now, before we take a look at the pipeline, I think what's more interesting is how my repository is structured. So let's start with my code. What I'm doing here is I'm utilizing the relatively new proxy integration type by API gateway. Just return an HTML body straight to API gateway. Before we take a look at exactly what I'm doing here, let me just uncomment a piece of code here. And then just commit it and push it. And that push is actually going to trigger my pipeline. Now we're going to take a look at that in just a few minutes. Now, as you can see, the first line that we saw up on the web page basically just says, welcome to my stage. I'm using an envar to define that stage. And the second line, which I just added, basically just gives me the time in a certain time zone. Now, the way I'm doing that is I'm using an npm package called time. And I just give it a time zone, and it gives me back the time within that time zone. This is my code. Pretty simple, nothing very innovative here. Now, this is my function, my template. Now, the cool thing I want to show you here is that I'm defining my environment variables together with CloudFormation parameters. And that's the way you can actually define your envars per stage that you're deploying to. Let's understand how that's happening. I have my CloudFormation parameters defined right here at the bottom. And then I have two JSON files. One is called beta, and one is called prod. Now, each one of those files is defining my parameters for that given stage. So for beta, I have a time zone that's defined as LA, and the stage name is beta. And for prod, the time zone is New York, and the stage is prod. Now, we're going to see, when we take a look at the pipeline, we're going to see how I'm actually associating each file with each stage in the pipeline. So the next file that I'd like to show you is my buildspec.yaml. And buildspec is the file that CodeBuild uses in order to run your builds. I'm defining my commands that I want CodeBuild to run here. So the first one, as you can see, is npm install. I'm installing my package that I'm using in my code. And the second command is the package command, the same one we ran on my computer just a few moments ago. I'm giving it a template file, an S3 bucket, and a name for an output template, which is output SAM. Now, another thing I have to define within my build spec is my output artifact. And the output artifact is what is going to be used by subsequent stages in my pipeline to deploy my application. So I have to specify the files that I'm interested in putting into that output artifact. The first one is the template, the new template that has the code URI properties. And then I'm specifying the two JSON files, the two files that I'm going to use to specify my envars per stage. So just to do a quick recap, my repo has my code, my template. It has two files that define envars per stage. And if I had more stages, I would have more files, more JSON files here to define the values of my envars. And lastly, I have my build spec file, which allows me to define the commands that CodeBuild is going to run and to generate the output artifact that I'm going to be using to deploy my application to multiple stages. Now let's take a look at the pipeline. And as we can see, the source stage has completed, and it's now building my application or packaging it. And it just succeeded, and it's going to start deploying in just a little bit. So let's try to understand what we're seeing here and how CodePipeline actually operates. So the source stage is actually continuously polling my repository and the branch, specifically the branch I specify within that repository. And when it detects a git push, it takes a snapshot of my repo and then passes it along as something CodePipeline calls an output artifact to make it available for subsequent stages in my pipeline. So if I take a look here, you can see that the first line in that configuration pop-up is the output artifact, which CodePipeline refers to as source. Now, source is going to be the input artifact for my build stage. And the output artifact, packaged artifact, is going to be what we generated in our build. Next, you can see that we have our deployment stage, our first deployment stage. And CodePipeline doesn't have access to the CLI, so I don't have my deploy command here. But it does have two separate actions, two sequential actions, for create and execute change set. Now, the cool thing about that is that I could actually interject another action right in between these two, which is called a manual approval action. And if you wish to do so, you could have people, an administrator, for example, actually review the changes, review the delta, the change set that has been created. And the pipeline is going to stop until someone comes, views the changes, and clicks, I approve. And then and only then, the pipeline is going to continue to the subsequent actions and stages. So that's out there for you to use if you wish to do so. Now, the way the create change set action works is it receives the input artifact, which is the packaged artifact. And I have to specify the stack name and the change set name. And then I'm specifying where the template is located. So as you can see, I'm specifying that within packaged artifact, its name is output SAM. And I'm also specifying the configuration file. So my beta.json, that includes my environment variables. After creating the change set, all I have to do is essentially just execute with the stack name and the change set name, and that's going to apply the changes to my resources in my account. Now, as we can see, the beta stage has completed. So we can just jump over here and see that it's been updated with the time in LA. And if we go to prod, we're going to see the same thing because we haven't passed our tests and deployed to prod yet. So let's talk a bit about our test stage. I'm using Ghost Inspector here. Let me just quickly show you what other actions I could have. So what Ghost Inspector does is it's a simple UI testing tool that allows me to test a flow in my web page or my web application. Now, I'm just using it to basically see that a text appeared on the screen. Then I know that my web page has loaded, and that's it. You could use it for much more complex UI workflows in your web application. Now, another tool that you could use here is something like BlazeMeter or Apica. And what Apica does, for example, is it can generate a load test for you. So you can generate a load test and have a large number of users or simulate a large number of users pinging your API for hundreds or thousands of times per minute and see how your application is handling that. And you could specify bars such as if there's more than this percentage of errors, or if latency is more than this number for this percentage of API calls, then pass or don't pass my test. Now, once my simple test has succeeded, I am then using another deployment stage to deploy to production. And this deployment stage looks exactly like the beta deployment stage we just saw. I'm actually providing the exact same template, which then links to the exact same deployment package. So again, each stage here is going to look very similar to the previous one. So all of my deployment stages are going to provide the same stack of resources. Now my prod deployment has succeeded. So let's take a look at my prod web page. See that it now shows the time in New York. OK. So we saw how we could use CodePipeline with CodeBuild and CloudFormation to pipe a SAM template through an automated release process. Now, we started with defining a SAM template, defining our serverless application. We then saw how we could deploy that application using CloudFormation commands. And then we saw how to automate that process, how to create a release process that automatically builds, tests, and deploys my application. Now, let's talk about how I can troubleshoot my application. So whether you're a serverless developer or not, you have to have an efficient, easy way to both monitor your application and troubleshoot it in case you're getting some errors or something happens. So the way you can do that today is, first, you can monitor your application using CloudWatch metrics. And there are 4 metrics that we provide out of the box. So number of invocations, average duration, number of errors, and number of throttles. You could, of course, create any custom metric you would like. And once you identify an issue, you can use CloudWatch logs to dive deeper into that issue. And today, every invocation generates a start and end timestamp, and also a report log entry that specifies the memory that you allocated to your function, the memory actually used by your function, execution time for your function, and billable time for your function. Now, you can, of course, build on that and have extra instrumentation and visualization from some of our partners, such as Datadog and Splunk. But the issue with logs is that they only provide you with insights into what's happening within your execution, within your function. They don't provide you any information on the Lambda service overhead, what's happening within the Lambda service when we're actually running your function. In addition, it's not easy to get a breakdown of downstream calls or what's happening with the subsequent resources or services that you're calling to from within your function. Now, that's going to change in a few weeks when we launch our integration with X-Ray. So X-Ray is a new service that was announced in preview today. And Lambda integration is going to be coming soon. Now, what X-Ray does is it collects data about requests that your application serves, and then provides you with a host of visualization tools to make sense of that data. And so specifically, let's start with something called a service map. And the service map you're seeing here is actually for a function that has a downstream call to a DynamoDB table, to DynamoDB. Now, the 3 nodes you're seeing here are from left to right. The first one represents the Lambda service. The second one, your actual function, so the actual function's execution. And the third one represents a DynamoDB table, DynamoDB, the call to DynamoDB that your function made. Now, the two quick insights you can get here are which one of these nodes or items introduces latency. As you can see, in the middle of the node, you have average latency per node. And secondly, you can quickly see which one of these is generating errors, because the color that you see here that is green is going to change if you're receiving 400s or 500s. So let's say you looked at the service map. You found that you had some sort of issue with the Lambda service. You want to drill deeper into that. You want to see what's going on in there. So the next step would be to take a look at the trace view. And what you're seeing in the trace view is a zoom in of what's happening within your function or your service or the Lambda service. Let's start with the top segment that we're seeing there. The top segment actually represents the entire time since your request entered Lambda and up until it exits Lambda. Now, the small node beneath that is the dwell time. This is for an async request, and Lambda actually queues up every request before we execute it. So as you can see, for this specific invocation, the function spent 6 milliseconds in the queue. We then have our first attempt at invocation, at invoking your function. And now that attempt succeeded. As you can see, we returned a 200. And the reason it's numbered as number 1 is because you could have 2 more tries before we say this function or this request failed. So if we had additional invocations here, you would see them in this trace view. Now, the next segment is your actual execution time, the actual time that your function ran. And the thing to note here is that the delta between the beginning of attempt 1 and the beginning of the user function is the actual time it took us to initialize both the container to run your function in and to initialize your own function. So you actually have a quick insight into that as well. And the last subsegment we're seeing here is the DynamoDB call. We can quickly see that it returned a 200 as well. And that to the right, it's a bit small, but you can see that it actually called put item. And you can see the name of the table that it's called put item on. So that was just a quick sneak peek into what is going to be coming pretty soon. You could use the service map to quickly identify any errors or latency issues in your request path. And once you identify an issue, you're going to be able to zoom in and see a breakdown of what exactly happened and hopefully quickly identify the root cause. So let's review what we did here today. We started with defining an application. We saw how we could use a SAM template to define all the resources within our serverless application. And then we saw how we could use new CloudFormation commands, package and deploy, to efficiently and consistently deploy my application across environments or accounts. Then we saw how we could use CodePipeline, CodeBuild, and CloudFormation to automate that process. And lastly, we talked a bit about how to troubleshoot an application. We saw what we have today, and that very soon we're going to have a new, totally different way to troubleshoot a serverless application. Now, what I would encourage you to do after this session is, first of all, go on GitHub, check out SAM. It's open source, so you can submit issues or pull requests, and we're going to look at and honor all of those. You can visit the Lambda console to download any blueprint or export your own function as a SAM template and see how that looks like and play with that. And as always, we encourage you to go on the Lambda forums, interact with us, send feedback, comments, and questions. As you know, most of our roadmap is driven off what we get from you guys. So we definitely encourage those kinds of interactions. So thank you for your time today. And unfortunately, I can't take questions from the stage, but I'll be hanging out outside the room and happy to address any questions you might have over there. So again, thank you very much for coming.